So standard deviation, by the end of this, you'll be able to determine with your calculator. There is a way to figure it out by hand. If you'd like to research that on the internet, there's 4 easy steps to do, but I'm not going to show you that today. We will do everything based on the calculator. But a quick overview of standard deviation is a relationship of the average. The standard deviation tells us the set on average, how far a data point is away from the mean. Let me put that into student terms. Let's say you have a set of numbers and you calculate the average. So for instance, I give a quiz and the average score was an 80. All right, so that means on average people scored an 80, but you really don't know if that was an 80 based on the fact that the numbers were really spread out. Maybe some people got in the hundreds and some people got in the 50s, or you don't know if actually really a lot of the scores came really close to 80. Maybe it was a 79, a 77, 81, 82. So it would be good to know where the spread of data was. Introduce the standard deviation. The bigger the standard deviation, the larger their spread was. So if the standard deviation for this quiz was 10 and my mean, my average was 80, that means most people scored between a 70 and a 90. All right, does that make sense? If the standard deviation is 10, then most of the scores came between 70 and 90 if the middle, the average, was 80. But if the standard deviation is smaller, let's say the standard deviation is only 2, and my average was still 80, that means that most of the scores were between a 78 and an 82. So the standard deviation can go on either side of that average. All right. So we kind of understanding how this would be important for statistical data if we're trying to figure out trends or trying to figure out, things about baby chicks. You ready for some baby chicks? Cute little baby chicks. It's baby chick season. Does anybody have a chicken coop? Anybody do their own eggs? A farm is studying the weight of baby chicks, and after 1 week of growth, they find the weight in ounces of 20 chicks. So the weights are shown below. So 2 ounces, 1 ounce is 3, 4, 2, 2, 3, 1, 5. They don't have to be in order. It would be nice if they were, but for this standard deviation, we're not going to do all that. So the weights are shown below. We want to find the mean, the interquartile range, the difference between the lower quartile and the upper quartile, the middle lower and the middle higher, and the standard deviation. We're going to round any non-integer values to the nearest tenth, and we're going to use appropriate units in your answer and give an interpretation of the standard deviation. Whew. Sounds like a lot going on there. But with just one button, our calculator will do all of this for us. So that's a pretty cool thing. But in order for the calculator to do it, it must know the values that we're going to use. So take out those calculators, and we're going to do the same thing we've been doing. Go to the stat button. Boom. And you need to enter a list. So go ahead and press enter, and we're going to enter a list. If you've got old lists in there, old data, let's clear them out. So up to list 2, clear. Go down and it will disappear. Over to list 1, up to L1, clear, go down, and now you've got a clean slate. So I've just cleared my list and entered it all 20 weights into list 1. I now go back to the stat key. So the stat key is where we edit the list. We got to go over 1 for the calculator to do anything for us. And this time, what's that? You guess something? What's that? We're going to go to the very first option, 1 var stat. So we're going to press 1 or hit enter. Make sure that for the newer programs, you see L1 here. So for those that have a little bit more than I do, L1 has to be the number there. Go ahead, go down to calculate, press enter, and wow, that's a lot of data. All right, a lot going on. The X with the line over it, that's your average, 3.7. So let's get that down for the mean. Oops. So here we go. For those of you that maybe didn't have a calculator, now it's time to get active. X with the line over it is the mean, and the average is 3.7, which puts the average rate of a baby chick at 3.7 ounces. About this a few days ago. So this is the range, the difference between the highest and lowest, but between the Q3 and the Q1. And remember that this is the upper quartile, and this is the lower quartile. We're missing the median, all right? So this is the If we're looking at this in terms of a box, it's the Q1 here and the Q3 there. We're not taking into account the middle line, which is the median. And this kind of helps us out because it's kind of relating the standard deviation to how far away we are to the median. In terms of the box and whisker plot, standard deviation is along the lines of the mean. So kind of a similar concept here. All right, let's take a look at those. Does the calculator give us that information? Well, if we scroll down a little bit, it will. All right, it does say that the Q3 was at 5, the Q1 was at 2.5, and the median was at 3.5. All right, so it gives us all of that stuff if we wanted to actually make a box and whisker plot, which is pretty cool. So we're just going to do 5 here minus 2.5, and turns out that 5 minus 2.5 is in fact 2.5. So the range of this is 2.5 in terms of the interquartile range. Let's compare that to the standard deviation. Now the standard deviation is a really cool looking thing. It's got this little circle with a long top and then an X next to it. So that is the standard deviation symbol. Kind of. I guess you can think of it as an O with a really long tail coming off of it. So that is a little bit further up in your calculator, and it is actually right here. It's under the SX. This little circle with a little tail on it is your standard deviation, and that is putting it at 1.73, rounded to the nearest tenth. It's really 1.7. So 1.7. We said that the mean is 3.7, okay? Now if the standard deviation is 1.7, I'm going to add it and subtract it to really kind of get the understanding of how much these baby chicks weigh. So when I subtract it, I get 2 ounces, and when I add it, I get 4 here, 5.4 ounces. So let's use that to have a quick discussion about baby. How many soda drinkers do we have out there? All right. Explain why the deviation is different. If soda A is a diet soda, and older people are drinking that with a higher spread of data, that's going to create a higher standard deviation. And soda B has a values that are closer together, that's going to create a standard deviation that's lower. So standard deviation helps you see how close the data is to the average. The mean only gives you one value instead of like an interval or a range of data. We said that soda A had a higher end of a 38, a 44, and a 40-year-old drinking it. So soda A has a higher or a greater diversity in age because of the difference between the high and low is larger, and that is going to create a larger standard deviation. There are 2 forms of standard deviation. There is a sample version, all right, and there is a regular version. The sample is for when we have a group of people from a larger population. So a sample just represents like you guys would be a sample of the Central Square students. All right, you'd only be a smaller group of everybody. So in this case, let's look at the sample standard deviation for both of these. So we go back to the calculator, we go back to the stat button, and we get ready to edit our list. Okay, so here we go. Let's hit enter. Let's clear out list number 1, and we're going to enter in soda A. So 18, 16 deviation. So here we go with the stat button. Now that we've entered our list, we go over to calculate, 1 over. We press 1 var stats, so we press enter. And again, make sure it's list number 1. Make sure that you have the right list entered before you hit calculate. And the sample standard deviation is the SX. All right, so there's our mean, our average. Average soda drinker in sample A is 26.7, or 6 repeating that is, years old, so about 26. And then the ages for the sample would range by about 9 years, plus or minus. So let's go ahead and get that down. That the sample standard deviation, right from the calculator, is 9.0, 9.1 if we rounded to the nearest tenth, with an average of 26.6 repeating. So you could subtract 9 from that 26 and find that most people are between the ages of 17 and 35 for our soda drinkers. 17 to 35 of the people that were surveyed. Okay. Other standard deviation, yes, you can see that it's a little bit different. This is 8.7. So if this was just the group, just these 15 people, the standard deviation would be a little bit smaller. But because we're talking about a sample of a bigger group, it calculates it slightly differently and causes the standard deviation to be a little bit higher. So I've got that information for you right here. Yes, because if this represents a sample of the larger group, then the standard deviation for soda A would be even greater. We are working with every single possible data point. We call that the population standard deviation, okay? And this is the regular weird looking symbol with an X next to it. And if we have only a sample, that's when we go with the SX, because that sample represents a larger group, all right? Last one, let's kind of close things out. Which of the following data sets would have a standard deviation closest to 0? So almost no deviation from the mean. All right. And, I think we now understand what a deviant is. Somebody that's deviant is what? Do they go with the rules or against the rules? They go against the rules, right? So if your standard deviation is really close to 0, what do we expect these numbers to be? Really, really bunched, right? So which one of those data sets is really, really bunched? Doesn't really break away from everybody else. 3, right? 11, 11, 12, 13, 13. There it is. Because this would be the average. That's, not just the middle, but it's the average. And then on either side of it, it's really close. So that would have the lowest standard deviation. Okay, and that's it.